In this tutorial, we will be learning the basics of SolidWorks. We'll be creating this basic sim motor mount created out of a piece of aluminum angle bar. We'll learn how to make the part itself, put it into an assembly, and then create a drawing. To start off, we need to create a new part. Go to File, New, select Part, and hit OK. Parts consist of two elements, sketches and extrusions. A sketch is a 2D drawing of what we want the part to look like. This can then be extruded, so it creates a 3D model that can be manipulated in SolidWorks. We're going to start off in the extruded boss/base, and then click the front plane. This brought us into our sketch menu, where we have many entity tools, such as lines, circles, arcs, and rectangles. We then have entity manipulation tools over here. We want to start off by creating the face that interacts with the motor. This feature right here is what we're going to start off with. It has a straight line that curves around the motor and then goes back to another straight line. We will then create the center hole and then the 4 motor mounting holes. To start off, we want to create the profile of our motor. To do this, let's create a circle, click on the origin, bring your cursor back, and then click again. We want to hit for construction. What this does is it does not include this entity in the final extrude, but we can still use it for reference. It turned it from a solid to a dashed line. Any entities with dashed lines are reference geometry. We need to scale this so that it fits the profile of our motor now. We can go to our sim datasheet and see that the maximum diameter is 2.536 inches. So now we want to hit Smart Dimension, click on the motor, click again, and hit 2.536. This created the profile of our motor, and this is what we're going to work around. Now we want to start off with a line. Create a horizontal line underneath the motor. This will act as the base. We then want to bring our cursor up and make an angled line towards the motor. Notice how it wants us to create another line so we can complete the polygon. However, we do not want to do this right now. So we're going to hit Escape, then click the line again, and we're going to click this endpoint and do the same thing. Now we want to create that arc that goes around the motor. So we're going to go up to our arc tool, we're going to hit 3-point arc. I'm going to click this endpoint, then this endpoint, then click above the motor somewhere. Now we want this arc to follow the contour of the motor. So what we're going to do is we're going to click the arc, then click the motor, and hit co-radial. What this does is it not only creates a concentric constraint, but it also makes it the same radius as the circle, so it follows the contours perfectly. So we want to click on the arc, then click on the line, and hit tangent. What this does is it makes the line tangent to the arc, so it seamlessly flows into it. We want to replicate this on the other side. Now what we want to do is we want to create that profile where it goes from an angled line and then transitions into a straight vertical line. So we want to go to the line tool, click on the angled line, and then bring it straight down to the horizontal line. Hit Escape, go back to the line tool, and do the same thing. Now what we want to do is we want to select the 2 top endpoints and hit horizontal. This will create 2 lines that are perfectly the same size no matter where you drag them. To get rid of this extra material, we can't simply just click on the line and hit delete because it will delete the whole line. We have to use another tool in SolidWorks called Trim Entities. We want to select the line, and it will just get rid of the part in between the 2 endpoints. Now what we want to do is we want to make it completely symmetrical to the origin. To do that, we need to right click, hit select midpoint, then hold shift and select the origin and hit vertical. This makes it completely symmetrical. Now we just need to refine it with some dimensions. So we're going to click Smart Dimension, click a horizontal line, and hit 4. Now what we want to do is we want to create a seamless transition from the angled line to the vertical line. We're going to use a sketch fillet for that. We want to set the radius to 0.25. This will create a curve in between the two entities so that it seamlessly flows from one to the other, like so. Go back to Smart Dimension and dimension the remaining line segment to be 0.408. Now we want to adjust the overall height of the part. To do that, we need some more sketch geometry. So we're going to click the line tool and go from the top of the arc down to the bottom, and then hit escape, select the line, and hit for construction. Now what we want to do is go back to Smart Dimension and then dimension that line so that it is 3 inches. As you noticed, all of the lines turned black. This means that the entire sketch is completely defined. Down here, you can see that it is fully defined. What this means is that no matter if you drag any element, it will not move. Everything has a dimension, everything is set in place. So now we need to exit the sketch, and it'll ask us how deep we want to extrude it. We're going to go with 0.25 inches. When hit OK. Now we have a three-dimensional component. To manipulate it in SolidWorks, you can hold down the middle mouse button and drag, and it will rotate around. To pan, simply do the same thing but hold Control. To zoom in, you can scroll in and out with the middle mouse wheel. Okay, now we need to create that hole in the center of our part, which allows the motor shaft through. So we want to go back to Features and hit Extruded Cut. This is the same thing as a boss extrude, except instead of adding material, we're taking material away. Now it's asking us what plane or surface we want to do the sketch on. We want to select this surface. Instead of trying to manipulate this manually to line up our sketch, we can hit this button, the Normal To button, and it will make our camera perfectly perpendicular to the sketch. If you don't have this menu, you can right click and hit Standard Views. Now all we need to do is do a circle around the origin. Going back to our sim data sheet, we can see that the overall dimensions for that boss is 3/4 of an inch. So we're going to make our circle 0.8 inches in diameter. Now all we have to do is exit the sketch, and just like the boss extrude, it'll ask us how deep we want to cut. Because we want it to go all the way through, we want to switch this from blind to through all, and hit OK. Now we have our center hole. To create the motor mounting screws, we want to go back to Features and use another tool in SolidWorks called Hole Wizard. Hole Wizard is a nifty tool that has data for many different types of holes, taps, even metric and ANSI inch. So we want to go to Hole and select Screw Clearances. Because our sim motor uses 1032 screws, we want to make a screw clearance hole for number 10 screws with a normal fit. We want them to go all the way through, so we're going to switch the end condition from blind to through all. When we click the Positions tab, it'll ask us which face we want to make our sketch on. So we want to select that face and hit the Normal To button. As you can see, it added a point, and the yellow circle around it is a preview of what the hole is going to look like. Because our mounting holes are in a radial pattern around the center of the motor, we can simply just make a circle and then position our holes around that. So let's make a circle around the origin, make it for construction, and then give it a dimension of 2 inches. I'm going to delete this point so we can add a new one in the correct spot. We're going to select our point tool up here, and we're going to go on the circle and then select the point that is directly to the left of the origin. We're going to do that all the way around. Now we have our 4 holes. We're going to hit OK. And now we have our center hole as well as 4 mounting holes. So now what we're going to do is, because this is made out of angle bar, we need to make the other half. So we're going to go back to Extrude Boss / Base and select this surface. Hit Normal To and grab a rectangle. Go from one side to the bottom corner with the rectangle and give it a thickness of 0.25 inches. Now when I exit the sketch, I want to make our extrude 1.75 inches long. Hit OK, and now we have our angle bar. Next we're going to create our mounting holes, which are 1/4 20 tapped holes. Again, we're going to go back to the hole wizard, but instead of viewing a hole, we're going to do a tapped hole. We want to ANSI inch and make it tapped hole, not bottoming tapped hole. We want to select quarter 20, and we want it to go all the way through, so we're going to select through all again. Go back to positions and select our surface. Let's grab a rectangle and drag it across, like so, and have for construction. Go to Smart Dimension and make it the same width as our sim motor diameter, so we're going to make it 2.536 inches. We want to line it up in the same way we lined up our line in our other sketch, by clicking the midpoint, the origin, and hitting vertical. Now what we want to do is we want to make another rectangle for construction, and we're going to place a point on each corner of the rectangle. So we're going to drag our point onto the corner, and it will snap to a coincident constraint. We want to do that 3 more times around the rectangle. Finally, we need to give it some dimensions. Let's give it a width of 1 inch, a length of 3¼ inches, and then we want to make it 0.375, to the end. We want to line it up with the origin as well, in the same way we did the other. So now we have 4 fully defined holes that are not going to get in the way of our motor. So I want to hit the check mark again, and we have our holes. The dashed line around the hole is the maximum diameter of the tap, but it only shows us where the actual hole is, and that's the size hole you will drill when you're going to tap the hole. Finally, what we're going to do is we're going to get rid of these sharp corners by adding a fillet in the Features tab. I'm going to give it a radius of 0.25. It's essentially the same thing as we did over here with our sketch fillet, except we're able to use it in 3 dimensions. So we're going to click those 2 corners and then hit OK. So now it rounded off our corners.